Well, here we are. Welcome to the physics video lecture. Once again, Psci 168 video lecture, this time 27. And you'll see I have a couple of demonstration objects on the table here. There's the torch. These things we'll discuss. Here's a nice little steam engine. And what I'm going to do is discuss heat engines today. And we've talked about this already, so now we're there. Heat engines. And I'll go back to that mechanical equivalent of heat. So we have found that 1 calorie equals 4,186 joules. This is a food calorie, but it's really just a unit, a measure of heat, of thermal energy. And once you have this mechanical equivalent of heat, you could actually dispense with the calorie altogether. But we're keeping it because it's useful. Now, what we had seen was that you could do work and produce heat, right? That's why we're keeping it up this way. Force, friction, rub your hands together, produce heat. But what we want, so this is the friction way, but what we really want is take the thermal energy and via some mechanism get useful work. So that's this direction here. So thermal energy, it could have been expressed in joules all along, but the point is we want to turn it into useful work. Useful work, okay? And what's a good example of that? If you've ever tried to push a car, you're glad that the car has an engine that works. And you put gasoline in your car, there's your fuel. I should actually write under here, fuel. And it'll drive you up the hill. Let alone just pushing it on the level, will drive you up the hill. And what the car has in it is a heat engine. The engine in your car, unless it's a pure electric car, it's a heat engine. So automobile. Has a heat engine. Right? You start with the fuel, use red here, start with fuel, and end up with useful work. So that's the goal. And what I'm primarily going to do today is demonstrate these mechanisms, talk a little bit about how they function, what the principle is, and I'll send you guys out to get some nice pictures of these things. These, by the way, are called Christmas pyramids. So I can put that up here as our list as well. So for our demonstrations today, Christmas pyramid. I know you get very nice images of some rather large and ornate Christmas pyramids. And second example here is the steam engine. I'm actually going to get it to run and then bring it up to the camera. And you guys can get all manner of images for your book. Okay, let's start with the Christmas pyramid. The idea, and not going to work that well. There's a lot of breeze in this lecture hall here, and as soon as I let this thing, release this thing, it could actually start to spin on its own. See, but the idea is, and I will get a demonstration of this, is that I light the candles. The candles will release heat, produce a convection current, and get this thing to spin. Now you're saying, well, it's already spinning just because of the breeze in the room, but we can do a little better than that. And there's a particular effect that comes into play. So I'm just going to light these candles. These devices have seen better days, so we'll be lucky. Wish me luck. Okay, it's all one take, no edit. Okay, so we got the flames going on, and maybe it looks like it's faster or not. But there is a very important effect. It's the chimney effect, and that's what I think I can demonstrate to you guys. So I create a chimney with this tube here, and I make it so that you can still see the rotation. And now, in fact, it's going to reverse. Right behind the curtain here, I'm not getting this thing to move by hand, but rather I have a chimney, and that's funneling the air. The chimney is really crucial. Okay, so I'll do this for a couple more seconds. That's the condenser, was the chimney. If I make the chimney a little better, it really starts to speed up. Okay, so there's your heat engine, including the chimney. Man, I couldn't even planned it this well. It's really cruising. There we go. So that's the Christmas pyramid. See, without the chimney, you're just not going to get a good function. Okay, let's put that out before we start a fire. This one here no longer even runs. Okay, it needs a repair. So that was a heat engine. You guys know that even though that's not a butter candle, it is a candle. We're burning fuel. We're creating warm air. The warm air rises, from hot to cold, right? The convection current. And it causes the turbine to spin. And that is doing useful work. It's carrying the angels around. Down here, the angels. Okay. I'll stop this so that it doesn't run. So that is an example of a heat engine. And the chimney is really crucial because what we found was without a separation of hot and cold, it's just kind of random motion. By putting a chimney around it, I'm channeling that convection current, and I have a hot region and a cold region. So I'm really getting a true convection current there. And then as you saw, it really zoomed around. So that was a big success. So that's my first demonstration, the Christmas pyramid. And like I said, you guys want to get images. So homework, images. And you'll find good ones. Now the next demonstration is the steam engine. And this is a nice small functioning replica. And there's a boiler here. There's fuel that I'm going to ignite. It gets the water in there's a little window on the end, and there's water in there. It gets the water hot enough to make steam, and then there's a little connection to this cylinder here, very small, but I'm going to hold it up. When it's moving, I'll bring it up the camera. And it's going to turn this flywheel, and if we're lucky, it'll actually get this light to glow because we have a generator here. And here's, civilization in a nutshell, okay? Start with fuel and we get a street light. Okay, so I have to fire this up and hope it works. Okay, so we'll light our fuel. The old-fashioned way. Okay, there we go. So this is going to take a moment, if it works at all. So while that's heating up, I'll get a picture going of the steam engine. In fact, maybe I'll draw our Christmas pyramid just to label some things. Right, we have the turbine here, and we have candles underneath with their nice flames. Maybe a little red in there. Why not? Okay. But we want some work out of this thing, so there's the platform with the angels being carried around. Okay. And we get a convection current here. And of great importance, I'm going to go ahead and put that chimney here. I'll just say, note chimney effect. Very important, because what we have already here is we have T sub H down below where it's hotter, and we have T sub C up here. And that's, you know, encasing it in a chimney is enough to get a real current going. And these things were spinning around nicely. So there we go. Now this machine's about ready to rip. There we go. I'm going to carry it up to the camera for a moment. And yes, we have a light bulb glowing. Let's go ahead and show this to the camera. There's a little window on the end. Flywheel. Light. Okay, now you guys know what you want for Christmas. A functioning steam engine. And I'll do a little diagram for this thing as well, but we really have something good here. Question is, how do you turn it off? I don't really know. Remove the fuel. Hope the fire alarm didn't go off. And we'll see now that the fire's gone, it's just slowing down as the steam, that was a good run. As the steam is used up, dissipates. Good. And this thing is just cruising around backwards, as you'll notice, due to the breeze in the room. Okay. So that was a success. That was a success. So there's our Christmas pyramid. You want to label this. We have candles. There's our fuel. Okay. Candles. Have the fuel there. Right, the work is being done and that the thing turns. There's a separation of higher and lower temperatures. In fact, if the temperature were uniform, in other words, if it were just as hot above as it is below, it would have no reason to turn at all. Okay? You definitely need that temperature differential, and that's a convection current. And so I have the chimney effect there, but I'll also write convection. That's heat transfer by convection, but it's also doing some useful work for us. Okay, I'll do a little diagram of the steam engine as well now, and then we'll call it good. So for the steam engine, you need to be aware of these terms. We have fuel that's burning down here at the bottom. You get some red here. So everybody saw those flames. And we have a boiler. This one happens to have a window in the end, which is kind of nice because then you can see the water line, and I'll just indicate it right there. So yeah, it's not full, it's only partially filled. Above here though, we have a bunch of steam. I'll draw a water line. So we have steam here, and it's enclosed, so we actually build up some pressure. So we have to have some kind of connection, and we do. I'll just draw a tube here. Takes the steam to a cylinder. I'll exaggerate the size of the cylinder with the piston inside. All right, this goes to there, carrying some steam right inside here, transparent. So there's a cylinder, and we've got a piston here that fits in, and the piston has a connecting rod. So cylinder, again, I'll leave a little room here for, I'll show you why. So cylinder, and then there we have the piston, and we've got steam in there, and it's going to push the piston to the right in my picture, and that pushing is, there's a force times a displacement, there's the work, okay? It gets pushed to the right, there's work. It's connected to a, so this is the connecting rod. So these are the basic terms I want you to know. Is connected to a flywheel. That flywheel that you saw right here, the red wheel. That's the flywheel. And here's an interesting point now. I think everybody sees what's going on. Fuel burning, steam under pressure, pushes the cylinder to the right. I'm sorry, pushes the piston to the right. And via the connecting rod, it turns this flywheel that I have to somehow give some spokes. Okay. And so you can see what's going to happen. It's going to push this flywheel and make it do a half turn. Now here's the question. It did some work, turned the flywheel a half turn, but how are we going to get the piston back to its, right? How are we going to do the complete turn? Okay. How are we going to do a complete turn because there's pressure in here? And if it did work, then we would have to push on it, and we'd have to do the work, we'd have to give it back. So we got the work, we would have to give it back. That would not be a functioning steam engine. What we need here is a valve. And that valve, every half turn, releases the built up steam, the pressurized steam, into the atmosphere. So you have to have a valve here that opens and closes, opens and closes, opens to release pressure. Opens to release steam. And that makes this into a cyclic process. So we have the steam pressure, pushes the piston forward, turns the flywheels, doing work. Then the valve opens and the thing can just spin freely and push the steam out. That's your exhaust. Then the valve has to close and the thing can repeat itself. Okay, yeah, so make a nice picture of this in your notes. And you're going to look up this as well. So we need images. And you'll be able to find very good images for this. So you want to be really clear on what's happening here. Oh, by the way, this is referred to as an external combustion engine. So this is, I'll put a star here. Star, this is called external combustion. Your automobile does not have a steam engine like this. Instead, gasoline will be injected into the cylinder and exploded each time there's, each time the thing makes a turn. So external combustion is what I've shown here. Internal combustion is the kind of engine you have in your automobile. I'm going to consult the clock. This may be as much as we have to do today. A little bit more, but yeah, I want to send you guys out and find images of the Christmas pyramid, of the steam engine, and diagram what I just showed you here. And the ones you find online may actually have some nice diagrams of what's going on here as well. What I'm going to finish with, I'll do a little list here with the internal combustion versus the external combustion. In fact, since I called this the external combustion, I'll just put a note on internal combustion. Internal. Then we have our cylinder here. Okay, piston, etc. But what we do is we have a spark plug. So spark plug, I'll make a little red thing in here. There's a spark plug in here. So spark plug. And that sparks rhythmically, ignites gas. So we have to inject fuel in as well. Spark plug. And fuel is literally injected. And then it is burned, exploded right here inside. It's still a heat engine though, okay? Clearly still a heat engine. Fuel is injected and ignited. Then you have the same thing. You have to have the valves, you have to have the connecting rod, and so forth. Good. So go ahead, I'll write the homework again. We want images and diagrams, see what you can find. Christmas pyramid. And then the steam engine. Of various types. You know, there was a whole epoch in which the steam engine was really developed. So this is you could say this is an early model. There were railroad locomotives and giant ships engines and so forth. Very far developed. Steam engine and then internal combustion. So I have a fourth point here. Now this may have looked like the most humble engine of them all, right? We just have this turbine, but what you'll find is when you look into this, the modern steam engine turbines that drive our gigantic power plants actually use a version of this. Instead of one, there will be a whole stack of these kind of turbines or propellers. And the steam will be extremely high pressure, high temperature. So let me add this to your list. Steam turbine, this is important. I usually show a whole bunch of slides of these, but like I said before, you guys are going to go out and discover these things. Steam turbines, and what's really interesting is the kind that run a power plant and the kind that power a jet plane are closely related. So let's write jet engine as well. I think you'll enjoy what you find there. So that's our outline of heat engines. Okay, the whole purpose was to get useful work from a fuel supply, thermal energy. We'll see later that one can, here there's a T. one can dispense with the fuel and actually still have heat engines from solar energy. So that'll be a subject coming up as well. For now, this is what we have. Go ahead and look up some of these pictures. My next step is going to be a schematic diagram and a discussion of heat engine efficiency, and then we'll return to some more examples. Okay, good. See you guys next time.